Okie dokie then, people, here we are. I've made a couple of YouTube videos with various, ROIP, radio linking to computers related subjects, and basically myself and a few others have been doing this for specifically linking Tetra radios to the internet for approximately 2 years now, just over 2 years. And when we first started out, the other people that were doing this bought Tigertronic's Signalink. Now, when they bought it, they set it all up, and to begin with, it had appeared that it worked and it did the job. However, over extended periods of time, eventually we found that it wasn't so good. It wasn't so suitable for what we were doing. It's well documented. Please, by all means, Google this. The Tigertronic Signalink has got some sort of a noise issue. I haven't looked into it too much myself, but the noise issue is there. It's well documented. Plenty of people have complained about this. So what basically happens is you plug the Signalink into your computer, and what happens is you get a lot of noise on whatever waterfall display you're looking at. So for us it's TeamSpeak, and we're just looking at audio levels, and the capture background audio level is half scale, halfway across whatever available scale you have is just filled with noise floor. And so Vox activation thresholds have to be set above that noise floor, and so as a result, any intentional audio to get rid of the any intentional audio which is there to defeat the Vox, i.e. your audio, has to be set quite loud in order to defeat the Vox level that you've now set quite high. Bit of a pain, but we lived with it for a while. Well, to begin with, I didn't have the money for a Signalink, and so that basically kept me off the air. As a result, I began working on Vox circuits. Now, the first one I built was brutal and disgusting. This represents 2 years of research and design. This is the very latest that I can come up with when it comes to Vox circuits. This is it. This is the ultimate. I could make more features into this, but as a result the price would go up, the complexity would go up, the reliability would go down. This is bulletproof reliable, relatively cheap to make, and we'll take a look at this now. So all this is a Vox Activation Circuit. Audio comes in. There's a comparator circuit inside, which is based on an operational amplifier, and all that does is supply power to a transistor, and the transistor then powers a relay. The relay gives you your press to talk. So you have this supplied with audio from your PC, and it detects that audio and presses the press to talk switch on your radio for you. On the other side of things, your audio just comes in through an audio transformer, through one of your volume dials, and then back out again. You'll notice that my version has 4 dials. I've not made up any Gucci stickers for this yet. I will get round to it. I'll make up some kind of a front panel that's a little bit more pleasing to the eye with marked up on there. So what you've basically got is RX audio, TX audio, Vox sensitivity, and Vox delay. The delay and the RX and TX dials, the Signalink does have, but what it doesn't have is Vox sensitivity. With the Signalink, you've got 2 choices. You've got dumb and dumber, and that's your lot. If ambient noise around you is enough to trip the Vox, well, tough. You'll just have to live with false triggers, and there's no way around it. With this, you can set it anywhere from one side to the other. At one end, press to talk is activated permanently. With absolute silence, press to talk is activated. So that is, you know, as sensitive as it gets. You know, silence is tripping the press to talk. If you switch it right the way over to the other side, what happens is you've made it very dumb. And so you'd have to have an extremely loud noise to make it trip. And you can set it anywhere between those 2 points exactly how you want it, not how somebody else tells you you should have it. With this, you get to decide how you want it. So they're the dials. You've got on-off on the front. That's fairly self-explanatory. This LED shows power on and off. This LED shows audio coming in. This will actually flash in time with the audio, and I'll show you that in a second. And this shows the status of the press to talk. So in other words, whether or not the relay is tripped. On the back, we've got an RJ45 style socket. This is for the lead to go to your radio. Here we've got a USB socket, the type that your average USB printer lead would plug into. And here, external power. Right, now here's another thing. With the Signalink, it is powered from the USB line. Now, I can do that for you if you'd like me to do it. I can make one of these, and I can make it powered from the USB line. However, not all USB power supplies are created equal. If you've got a lot of USB stuff plugged into your computer, if you've got a load of hubs plugged in there and that, then you may start to see issues with current draw. This draws very little current, you know, it's a little op-amp, there's a couple of LEDs on the front, and the relay. The relay is probably the biggest consumer of current on this device. But I decided it was easy enough to give it an external power supply, and it also means that we can deal with higher magnitude voltages and currents. And what this means is that you can have a bigger difference between on and off. Take my word for it, it adds to the reliability. If you've only got 5 volts to work with in the first place, it's doable, it is settable, but I don't have any robots here to manufacture this stuff. I don't have CAD design software. You'll see the construction inside. This is all done by hand. I don't work in a vacuum atmosphere here, so it was easier and I believe more reliable to have external power supply. So it's just 12. You can stick pretty much whatever you want in here. It's not critical, but give or take about 12 volts. I think it'd be fine. You won't damage anything if you stick, you know, 3 volts, 4 volts, 5 volts into it. You won't damage anything. The relay just won't trip. The Vox circuit would still work, but the relay probably wouldn't, because it's a 12 volt coil on the relay. If you stuck much more than sort of, I don't know, 15, 20 volts in there, I think the LEDs would start to go pop, and you would get problems with the relay coil overheating. I imagine that would burn out eventually. Not a good experiment to try. Okay, so I've removed all the screws from the front here, and I've removed all the screws from the back already. Obviously I didn't want you to stand there watching me do that. And you remove the back, and that's what you're faced with. These cases are a little bit different to Signalinks, because mine does this, and the lid comes off. So if you need to get to the jumpers, which are just there, you don't actually have to take the whole board out of the case. But here's your RJ45 socket with the leads going to the jumpers. Here's your USB socket going to a sound card, a USB sound card. Here's your power supply, input, smoothing capacitor. I don't know how much good that's done, but I added it anyway. Okay, and so for this I'll remove the rest of it here. Okay, so we've got another board here with the on-off switch and the LEDs. As you can see, Now this is all fairly, it's the highest quality stuff I could buy basically. I'm still working on final designs for this really, but it's the highest quality stuff I could lay my hands on. You can see the dials, the backs of the potentiometers there. They are extremely high quality, better than the last ones I was using. This is the transistor, it's a TIP 122. This bad boy is scandalous. There's absolutely no requirement for it whatsoever. I could use something far smaller. This is capable of switching 5 amps. So it's just cruising along while it's doing the relay. It's not even trying. And that's the idea with this. I didn't want to build something that's right on the limit all the time. This will quite happily switch your car headlights on and off on main beam on its own without the relay. That's the level of reliability I'm trying to build in. This sort of section here is the Vox circuit, if you like, the Vox recognition, and this is the little operational amplifier which does the business for you. 2 transformers for RX and TX audio. Right, a quick word about this. On my Vox circuit, the ground for TX is separate to the ground for RX. You can join them together if you want to, but on my circuit they are separate. And you have access, you have the capability to keep them separate on the cable at the back. Also, those 2 audio grounds are separate from the press to talk ground. And the press to talk ground and the 2 audio grounds are all separate from the PC ground. Now if you choose to, you could jumper them all together. I've given you enough options to do that here. But basically it offers complete isolation. Your PC is in no way connected to the radio. The radio floats on its own. And that's the whole point of the transformers. There can be no ground loops because your radio isn't connected. As far as your radio is concerned, you've got an external press to talk switch plugged into the back of it, and you've got a microphone plugged into it, and you've got a speaker plugged into it. It thinks these transformers are a 600 ohm speaker and a 600 ohm microphone. We're running a con. That's what we're doing. So yeah, that's it really. That's the board. And as you can see, it's all handmade, it's all done by hand. This isn't done by robots in a vacuum. I have to make this. And as you can see, you know, it's not a 5-minute job. These things take me approximately 2 weeks to put together because they are complex and they never work first time. They do take a little bit of development. Okay, so I'm going to put it together now and we'll fire it up and I'll show you it working. We slide that into there and it all slides in. I mean, again, the idea of myself making it the way that I did was that you know, you're not going to have to take the whole thing apart like I've just done here in order to access the jumpers. You only have to strip it down. Just bear with me here while I get it all to clip in. There we go. Okay, yeah. You only have to strip it down as far as this. You just take the back off and then slide the top off, and that's it. And you've got access there to the jumpers. If I've not had any problems with snapping wires off in these jumper positions. I will supply approximately 1 meter of cable. I'll chop it up into little lengths. But the reason I've used multiple jumper positions there is that you can put, right, for instance here I've used a diode to stop the plus 5 volt line, which is what your press to talk is on your radio, back feeding into here. It's not really a problem, but that's what I did. I'll supply this pre-set up for your radio if you'd like me to do so. And another thing I can do is, you see these jumper positions, I can get another one of them and put the jumpers in and solder them in. And so what you'd do is you'd have a little jumper module like that and you'd just pull it out and put it in whenever you want. and I can make you one up for an SRM 1000, I can make you one up for an MTM 800, I can make you one up for D1700 hands-free kits, whatever you want. So I just want to go back a quick subject with the earthing, with the grounds. Why did I separate all the grounds? Why did I go to so much effort? I mean, Tigertronics didn't bother, and they know what they're doing, right? Well, no, they didn't bother. They tested it on a couple of HF radios and then bunged it out for manufacture. I'm going to make another video on another project I've been working on, a node in a suitcase, and it's based around an MTH 800 in a car hands-free kit. When I made that, I soldered all the grounds together, fired it up, and there was no audio in or out. I touched the control box for the MTH 800 and it was stinking hot. What had happened inside when I opened it was it had unsoldered the main 22 watt audio amplifier. It had got so hot it had unsoldered itself from the board. There was a pool of solder in the bottom of the box. So I knocked all that out and resoldered it, and luckily it came back to life. But the grounds have to be separate. They're not all 0 volts. So for that reason, my Vox circuit can do things like that. It can do things where the grounds have to be separate. Right. Time's cracking on here. Just a second here. I've got TeamSpeak running in the background. Just give us a second. Anyway, here we are. Put the back on, nice and simple. You get the idea. Put your screws in, and then it's all secure. Right, bung this down on the table. We've got bog standard USB lead, the type that you'd use for a printer. Okay, and you just plug that in the back. Now, just give us a second and I'll turn the PC speakers up so that you can hear what happens when you plug this in. Okay, did you hear that? That's the USB being recognised on the computer. Next up, what we'll do is we'll plug the lead. Okay, here is an example of a custom lead. This one is for the MTM 800. It's got a Motorola series accessory connector on the end of it, and we've got the RJ45 style socket there. Okay, so we take 1 times MTM 800. This is just an example, it could go into any radio. And we'll connect this up here. Okay, so there you go. The end of the lead is plugged into the back of the accessory socket on the radio. I'll just plug in power here, and I'll plug in the antenna. There we go, that's that sorted. And we'll just let the MTM boot up. Right, next up we've got the RJ45. Oh dear me. Oh dear me. We've come across a problem. Oh dear. What I should have done is screwed it all back together properly. However, I neglected to do that. No problem. Moving swiftly on. Okay, you've got your RJ45 lead and you plug that into the back. So now the PC is connected to the interface and the interface is connected to the radio. And the last thing is power. Simple little lead like this. I'll make you one of these up and you plug that in the back. Okay, nothing happens on the front until we hit that. Right, as you can see, you've got the blue light to say that you've got power. We'll bring the MTM a little bit closer. Hopefully you can see this. What I'm going to do is I'll just zoom in with the camera to make it a little bit easier to see. Okay, there we go. Right. So you can see my Supura there as well, the handheld. And what I'm going to do now is, this is the delay and this is the Vox sensitivity. So I can set the Vox sensitivity. As you can see there, that's it permanently on, and that's gone into transmit just there. And as a result, the MTM is transmitting, as you can see from the status LED there. And we've got it coming through on the Sepura. Okay. If I twist the dial a little bit for Vox sensitivity, we can just set it to the point. I just need to turn it over a little bit. There you go, it's disappeared. Oh, now what it's picking up there is minuscule amounts of RF. It's impossible to get rid of that because where we are right now on the scale is on a knife's edge between on and off. So all you do is you turn it up a little bit more, just a slight bit more, and that's that set up really. The next thing to set up is delay. You know how to do that if you've used a Signalink. So we can set it to on, and I'll turn this all the way down. So the delay is, okay, it's about a second. On, off. One Mississippi, two Mississippi. Yeah, it's about 1.5 seconds on minimum. I could make it less, I could make it more. It's entirely up to you. Alternatively, I can set it all the way over to the other side, switch that off. And as you can see, the delay is slightly more. Mississippi 1, Mississippi 2, Mississippi... Okay, so it's almost 3 seconds when it's all the way over. I normally have it set about there, give or take. TX, RX, I'm not going to adjust them because they're already set up. And that's pretty much it really. You know, you run your program on the computer, for instance TeamSpeak. Within TeamSpeak you'll tell your computer to look for USB audio codec, and that'll be your Vox circuit there, and that's it really. You set the levels up. The best thing about this is you've got the TX and RX dials on here, but you've also got the mic gain and speaker output sliders on your computer, so it's very, very customizable to anything that you want it to do. Okay, well I think the video's got long enough as it is. I've tried to go into as much detail as possible without boring you, but that's it in a nutshell really. Again, I can make this do any radio you'd like, analog radios, digital radios, DMR, TRBO, that sort of stuff. There's no problem with that at all. If you want it to do something like something exotic that I don't have the hands-free kit for, what I'll do is I'll make up a lead that doesn't have an end to go into a radio, and I'll put, I don't know, whatever you want, bullet connectors on the end of it, and I'll provide some more empty bullet connectors so that you can crimp your cable on there. There isn't really much else I can do with that. I can't replicate your hands-free kit if I don't have it. So I'll try my best to make up a custom lead. I will test it. I've got an MTM 800 here, I've got an SRM 1000 here, I've got a couple of analog radios, I've got various other bits and bobs, I've got a Sepura hands-free kit now, I've got an MTM 800 hands-free kit, so things are getting better for test kit. And don't forget also, if you'd like things realigning, just let me know. I cannot do Motorola's because as of yet we've not figured that one out. Anyway, thanks for watching and I'll see you all very soon.